Okay, start na tayo. Row indexes. Both rows and columns in data frame have labels called indexes. In vehicle data frame, rows are labeled by numbers 0, 1, 2, etc. Columns are labeled with text, ID, model, year, etc. So ito yung rows. Rows ito. Rows from 0, 1, 2, 3, 12, 9, 8, 6, 8, 9. Rows. Pababa to. At columns, ito yung mga labeled with text. Text to. And like ID, model, year, transmission. Ito yung mga tawag dyan. Mga types of ano meron dun sa vehicle. Anong ID ng vehicle, anong model ng vehicle, anong year, transmission, manufacturer, kahit ano. If we talk about the index of the data frame, we'll always be referring to row index. Default index. By default, data frame comes with the range index, where the first row is labeled 0, the second row is labeled 1, and so on. To confirm this, we can call that index attribute on the data frame. Or data frame, sabihin natin, anong data frame nito? Like for example, ibahin na natin tong vehicles, gawing computer, pwede, food, yun ang data frame. Kasi ito yung silbing like parang pangalan ng tawag dyan. Parang siyang spreadsheet pagka bago mo buksan, yung pangalan ng pangalan ng nagawa mong spreadsheet. Like computer shop, pwede cellphone shop, or kahit basta dyan lahat. Tapos pagka bukas, dyan yung makikita lahat ng mga information about sa main topic. Kaya sinabing data frame. Kasi siya yung frame nun. Ito, frame yan. Tapos sa loob ng frame, diyan makikita lahat ng information. So yun. If the data frame has the default index, the output will be range index. Start 0, stop number of rows, step 1. Kung indicating the rows labels start at 0, increase by 1 for each row. And before reaching the total number of rows since we started counting at 0. So, sinabing start at 0, dyan tayo magsistart. Kung sinabing starts at 1, dito tayo magsisimula. Sa 1 lang. Dyan lang tayo magsisimula. Masiskip na natin tong 0. So, start tayo sa 1. Tapos sinabi, increase by 1 for each row. Okay. Kung sinabing increase by 1 for each row, ibig sabihin, tig-iisa-isa na sila. Tig-iisa-isa. Pag sinabing increase by 2, mag-appear yung dalawa. Mag-appear yung dalawang row. Kaya yun sinabi. Tapos, and before reaching the total number of rows. Kasi wala man sinabing stop. Kung lalagay natin stop, for example, mag-start tayo sa 0, tapos stop tayo sa 4. Di mag-e-end siya sa 3. Yun ang mag-e-end siya sa 3. Kasi yun ang naka-indicate na sabi, stop 4. Kasi dyan tayo mag-stop. Ito lang ang makikita natin. 0, 1, 2, 3. Kaya yun. For example, a data frame with 3 rows might have index, range, index. Start 0, stop 3, step 1. Yun na yung sabi ko. In this range index, we start labeling rows at 0, stop before 3, and increase by 1 each row. The first row has the label 0, second row has label 1, third row has label 2. Yun ang ano ko. Yun ang ulit sabi ko. Magsa-start tayo sa 0. Sinabi, start tayo sa 0. Magsa-stop tayo sa 3, which is dito tayo. Mag-stop tayo. Stop tayo sa 3. Ito lang ang makikita natin. Kaya sabi, the first row has label 0, second row has 1, at saka 2. So, other kinds of index, both data frames and series can have other types of index. For example, let's call that value counts on vehicle type in a vehicle's data frame. Okay. Vehicle counts, ito yung ano, tawag dyan. Vehicle counts, ito. Okay, because ka na. So, vehicle counts equals vehicles, mga pangalan ng vehicles, ito. Klase, type siya ng vehicle. Vehicles, ayan. Tapos sa loob ng vehicle type, mga other types ng vehicles like sedan, SUV, pickup, van, passenger van, vocational, or cab chassis. Yan. Value counts. Ito yung lalabas dito. Ito. Ilang sedan wagon, ilang SUV, ilang pickup, ilang van, ilang passenger, ilang vocational. Kaya yun sabi, value counts. Here, each row is labeled with vehicle type as text if we call vehicles counts index. Ito. Okay. Kung input natin itong data frame. Data frame ay vehicle counts. Ito yung makuha natin dito. Vehicle counts equals vehicles type. May kita yung vehicle counts index. Tapos ito yung kakalabasan to. Index. Tapos lahat ng types of vehicles. Lalabas yung sedan, SUV, pickup, van, passenger van, shuttle bus, vocational or cab chassis. Tapos anong data type anong data type itong sa data frame? Data type nito. So object yun. Like an range index, this is an index consisting a list of distinct objects or string. Set an index, it is possible to restore a standard range index by calling the method .reset underscore index open close parenthesis. For example, if we call vehicle counts reset index, ito yung marireceive natin. Naka-reset na lahat. Ito yung kakalabasan to. Note that on the column index in the reset index data frame is no longer the index. Thus, column containing the old index values pre-reset. The index is calling reset index is a range index from 0 to 5. So, problema natin na biglang nawala yung Jupyter natin. Kaya ulitin natin to. So, instructions na natin. First, run the setup cell to import libraries and dataset. Then, in the next cell, display the index of the vehicle data frame. So, ito yung setup. Itong una. Save na natin. Tapos run. Yan, okay na. So, sabi, then in the next cell, display the index of the vehicle's data frame. Use the index attribute. So, ilalagay na natin yung data frame natin. D equals dot index. Save na natin. Tapos run. Okay. Test work. Okay lang. Nawawala. Wait lang. Nawawala kasi. Pasensya na kung ganyan nangyari ibang mga other videos ko. Ibang mga previous lessons. Nagkaganyan po siya. Kaya dito set natin. Save. Save natin. Tapos run. Okay. Equals index. Okay. Equals run. Tapos test work. Save. Run. Okay. Good na tayo. We have already defined as the transmission count series. Display the index of the series. So, define transmission counts. Display the index of that series. So, since tapos na tayo dun sa vehicles, sunod naman tayo dun sa transmission. Define. We have already defined. Display the ang series. Ang tinutukoy na series ay yung transmission counts. Transmission. Counts. Counts. That index. Okay. So, save na natin. Tapos run. Test work. Ito. Dito yung okay lang. Transmission counts. Use the index. Okay. Sige. Save natin. Run. Tapos save natin. Run. Okay. Listen tayo. Reset the index of transmission counts to range index and assign the result of transmission counts reset. So, get muna tayo. Call reset index. So, gawin na natin ay bigay natin itong ang index na natin yung gagamitin ay transmission counts. Tapos, dot reset the score index. Okay. Kasi, tawag dyan. Ito lang ang marireset. Diba? Naglabas itong itong nasa loob ng transmission counts. Yung auto, continuous variable, known, single, manual, transaxle, direct drive. Kaya i-reset na natin to. Save natin, tsaka run. Ayan. Kung tawag dyan. Pag na-reset na ito yung output. babalik siya dun sa data frame. Simula 0, 1, 2, 3, 4, 5, 6 rows, tama ba? Rows, columns. Hindi, tama. Rows pala to. Rows, tapos ito columns. So, test work natin to. Okay. Next. Sorting rows. Exploring dataset is easier if the rows have a predictable structure. For example, the vehicle's dataset would be simpler to inspect if we knew that the models were listed in chronological order. The syntax of sorted data frame or DF in pandas by particular column. Ito yung data frame natin. Kung anong data frame natin dyan nilalagay. Yan ang sabi ko, kung ano yung parang title siya ng title ng spreadsheet, ganun. Anong title? Like, vehicles, cellphone, ganun. Kaya, dyan ilalagay. Data frame equals data frame dot sort values, open parenthesis by column, close parenthesis. Sort values, open close parenthesis of data frame method. By is a keyword that receives the label of the column to sort by. By default, that sort underscore values, open close parenthesis, will sort from lowest to highest, or for text from A to Z. Passing false to the ascending parameter will sort from the highest to lowest of C to A. So, kung true, ito yung from lowest to highest. Simula from A to Z. Kung sinabing false, magsisimula siya sa Z to A. Parang, mag-a-ascend siya. Tapos, bababa. Kung false, mag-a-ascend siya. Kaya, ayun. There, tawag dyan. Data frame equals data frame sort values, open parenthesis by column, ascending. Kung gusto mo hindi, walang, same din, pag, kung ascending, ilalagay ascending true, same din siya. Sa walang ascending, same din siya. Pero kung gusto mo ng, ascending, false, false natin siya. Like, simula sa baba hanggang sa taas. So here's a sample of calling. Dot sort values by year. Ascending false. Ito yung ito yung original. Diba? Nagkahalo-halo na to. Halo-halo ang year. Okay, guess ko siya. So, depende siya dun sa ano bang klaseng column. Anong column ang tinutukoy niya? Like, for example, tawag dyan, ID. Kung nilagay na yung by, kaya sabi, asan na to? It's a keyword that receives the label of the column to sort by. So, pipili tayo kung ano nasa column. Sa taas, ito. Anong klaseng like, anong klaseng model, anong klaseng year, anong klaseng transmission. Yun. Tapos, kung nilagay natin by, anong klaseng type siya? Anong data type? Sabihin natin, lagyan na natin ng best MPGE. Tapos, lalabas siya. Kung original, sabi 28, 21, 29, 18. Once na nilagay na yung data type ay best MPGE, mag-appear siya. kung ilalagay natin ascending false, parang tawag dyan, nag-a-arrange. Na-arrange siya by number. Arrange siya from lowest to highest. Kung gets, okay. Kung hindi, sorry. So, sorting the index. Calling that sort underscore values, open close parenthesis, you only sort values by column. To sort rows by the index values instead. Use that sort underscore index, open close parenthesis. There's no need to specify a parameter since the method will already be short by index. Like that short values passing true or false to ascending continues over the next sort. Okay. Next. So, tayo dun sa Jupyter. First, run the setup cell. Run natin yan. Kasi hindi gagana. Pag hindi gagana ang next. Wait lang. Parang mawala siya. Yeah. Yeah, yun. Ayun. First setup. Run natin to. Run. Tapos, sabi, sort vehicles by here from oldest to highest, newest. So, input ko na siya. Sorry. So, ilagay natin to. Kung ang ginawa ko ay vehicles, kasi ang data frame natin ay vehicles, tapos vehicles ulit. Lagyan natin sort values by year. Kahit hindi natin ilagay yung ascending. Kasi, either, pwede naman ascending, true, or kahit iwan mo na ng blanco. Tama ba? Alam kong hindi Will sort, okay. Kahit walang kahit may ascending true or wala, na-sort pa rin siya from highest to lowest. Kaya sinabi, the lowest to highest, ibig sabihin, false siya. So, save natin. Tingnan natin kung from lowest to highest. Okay, hindi pala. Okay, huwag natin ilagay na itong ascending. Pero depends naman sa'yo kung gusto mo. Ilagyan ng ascending true. Pero same pa rin siya. So, run natin. Nakita natin by year. Kasi yung year. Ayan. From lowest to highest. Ito natin. Simula 1990, lowest. Pinakaluma. To highest. Hanggang 1994. Kaya, test work natin. Okay. Okay. Sort vehicles from highest to lowest. Ito yung part. Same pa rin siya sa second part. Same siya. Pero, papalitan na natin tong ang column natin. Yung by keyword. Papalitan na natin from by year. Palitan na natin ng PSP and PGE. Since sabi, highest to lowest, mag-ascending siya sa false. Kasi false ay from highest to lowest. So, save, run. Ito yung result. Asan na siya? From highest, ayan to. Okay. 150, pinaka-highest nito, to lowest, hanggang sa 148. So, MPG stands for miles per gallon equivalent in standard calculation used to compare different fuels like electric with standard vehicles. Field-based MPG is highest MPG reported under all circumstances, highway driving versus city, hybrid performance, etc. So, save na natin. Test for, okay. We've already created a series year counts that counts the numbers of models per year in dataset. Sort the index of year counts to put in series in chronological order from oldest, lowest to newest, highest. Does the number of models go up over time, or are there years where it fluctuates? So, hint natin. Call sort index. So, gagamitin ang index na natin ngayon, ang gagamitin natin index ay year counts. Kasi, nakasabi, here's where it fluctuates. Para malaman na natin ang year. Para malaman natin yung year ng vehicle. Like, 1991, ilang ng vehicles. 1992, ilang vehicles. 1993, ilang vehicles. So, ilalagay natin year counts kasi yun ang data frame natin. Year counts, that's sort index. Sort index is like yung sabi ko before ay index ay para siyang spreadsheet. Ganun. Dahil nilagay sinabing sort underscore index kasi parang isa-sort yan from tama, lowest to highest. The oldest one. Nagsisimula dun sa oldest one, sa 1991, hanggang sa highest. Hanggang dito. Tapos ilang year, ilan ng vehicles sa 1991, ilang vehicles sa 1992, ilan. Ayan, may kita yan. Ilang vehicles, ilang data type ng vehicles. Ilan yan? Yan, makikita natin dito. Ayun. So, save natin, tapos run. Ay, lalabas to. Na sort ang years. Sorry. Simula 1991 hanggang 2023, which is this year. So, test work natin. Okay, next. Selecting specific rows. Sometimes we're only interested in looking at certain rows and columns of the data frame. We can select sections of the data frame using two methods, .loc and .iloc. Hindi ko alam din sa iloc, pero let's try to understand na lang. We'll explore how both of these work using the following mini data frame. Ito. Before demonstrating the .iloc and .iloc, i-reset na natin to. Kasi di siya gumagana minsan. Kaya kailangan i-reset natin to. We'll start off data frame by year. This isn't necessary to use iloc and iloc, or sabihin natin iloc open close bracket, but you'll make the difference between them clearer. Okay. Pasensya din sa asa. So, using iloc. The iloc index works using as index labels, and the syntax is ito yung database, ito yung data frame natin. Data frame, lock, tapos list of rows. List ng rows, tapos list ng columns. For example, ito yan. For example, data frame, pangalan ng natin, data frame natin, location, tapos open close bracket, sa loob niyan, 03. Sabi, list of rows, 0. Asa na siya? 0. Pasensya na. Wait lang. Ayan, back na tayo ulit. So, saan tayo? Okay. Sinabi, location natin ay 0. Ito, 0 at saka 3. List of row labels. List ay nasa 3. Ay, tama ba? 0 ay sa row labels. Tapos, okay. Nag-gets ko na siya. Ito. Ford. Tapos, number 3, Toyota. Tapos, saan bang sang column? Parang siya, buy siya. Pero, wala siyang parang buy. Parang, saan location? Saan location tong 03? Saan location siya? Like for example, sabihin natin, tawag dyan, 03, tapos year. Ang lalabas dyan dito, sa selection, lalabas na year. Anong year ng 0? 2017. Anong year ng 3? 2020. Mag-appear siya. So, next. Using ilog. Ilog index works using the position of the rows and columns instead of their labels. The syntax is essentially the same except that the list contains positions instead of labels. So, data frame, ulit, pangalan ng natin, data frame natin, ilog, hindi ko sure kung anong ilog, pero sa akin, parang position siya ng rows. Saan position yun? Anong position ng row? Anong position ng column? So sabi, where? Both row positions and column positions starts at 0. So siya sa 0. Rows are counted top to bottom. Columns are counted from left to right. For example, data frame, .ilog, 0, 3. 0, 3. 0, 3. Ito. Pero sabi, 0 lang. Mga related lang sa 0. So, 0. Kung Ford, lalabas din. Kasama din to. Hindi naman siya nakasama dun. Pero, same din siya dun sa make. Same siya. Ford din to. Kung 0 ay nasa, 0 naka-indicate ay Ford, lalabas din. So here is tree list. Instruct ilog. So select only first row position 0. The fourth row position 3. The column list here instructs ilog to select the first column which the column has labeled make. It is very common to wear the call off by 1 errors by starting position at 1 instead of 0. For example, it's natural to write the list 1, 4 to select the first row. Select the first and fourth rows instead of this 0, 3. Be patient and remember to check this if you're receiving wrong selection from iLog. So start na tayo. First, run the setup cell. Run natin. Okay. Use .lock to select first two rows, all 2023 models, in the manufacturer column. Assign the results to the manufacturers underscore 2023. What labels for the first two rows? Okay. Gawin natin ay anong data frame natin? Manufacturers 2023 dot lock location score ay open close bracket first two rows 23 gawin natin 1940 tama ko 1940 to lahat ng 2023 718 tapos saan siya nakadikit? All 23 models. Ay, hindi. Kaya sabi, ay, yan. Sabi, lahat na naka-indicate sa 2020, lahat ng itong rows, rows na 2023. So, gawin natin, run natin to. Manufacturers. Wait lang. Manufacturers. Ay, mali. Kasi mali ako. Dahil nakalaki na data frame ay vehicle, dapat vehicles, hindi manufacturers, mali ako. Vehicles. My mistake. Vehicles dot location 1947-18. So, save and run. Ayan. Itong 2023 lang. Test natin. Then you can select two rows. Okay. And the manufacturer column. Assign the results to manufacturer. Baka ilagay natin ng manufacturer. Manufacturer. So, ito lang. Ito check natin. Test work. Manufacturer column. Assign the results to manufacturer 2023. Okay. Use iLock to select first two rows. All 2023 models in the fuel column assigned to result to the fuels 2023. So, lagyan natin ang data frame vehicles dot iLock. Sabi, fuel 2023 models. So, input natin ulit 1940 718, tapos comma, open close bracket, fuel. Yan, papalitan na natin sa fuel. Okay, diba? Okay. Run natin. Wait na. Hindi. Anong column? Okay. Ito 0. So, titingnan natin. 0, 1, 2, 3, 4, 5, 6. 6. Lagyan natin 6. Tapos, save, run. What are the positions starting at 0 of the rows and columns? 0 to 6. Tingnan natin. Starting at 0 tayo, kaya nilagay ko 0, 6. Test natin. Okay. Lagyan natin 6 lang. Ito lang. Kasi sabi, first row in a fuel column. Ito, fuel. Fuel ng sa 1940 row at saka 718 row. So, wala natin ito. What are the positions starting at 0 of the rows and columns? Natin kung ano din. Okay. Hindi siya 1947-8. Dapat 01, okay. Pag iLock, nabibase siya sa 0, 1, 2, 3. Pag lock, 1940 to 718, okay. So, ano natin? Same din. Does work. Okay, next. Selecting ranges of rows. Instead specifying list of rows and columns with .lock or slash .ilock, we can specify a slice, which is like saying select all rows from row A to row B. Slices with iLock. If we want to select the first 5 rows of the data frame using iLock, we could use the list of row positions 1, 2, 3, 4. The slice reproduces a consecutive list by specifying where to start and stop using the syntax. Start, tawag dyan. Start positions like, magsa-start tayo dun sa 0, or mag-start tayo sa 1, start tayo sa 2, start tayo sa 3, tapos saan tayo magsa-stop. Like for example, start position natin ay 0, tapos ang stop natin ay 3 or 4. Ito lang ang makikita natin, 0, 1, 2, and 3. Beyond, start position is the first position to include. Stop position is one position beyond the last position. See, the last position to include. For example, yun ang sabi ko, magsa-start tayo sa 0, tapos stop tayo sa 5. Kaya ang result natin, 1, 2, 3, 4. Yun lang. Yun lang ang result. Makikita natin. Let's explore the practical example using our vehicle's data frame. The relevant section of the data frame is below. Suppose we want to select the first 3 rows in the model, year, and transmission columns. We will need 2 slices, one of the rows and one for the column. Rows, we want to start at the first row, position 0, at the end before the 4th row, position 3. The slice is 0, 3, which is include position 0, 1, 2, which means tatlong numbers lang ang magagalaw natin, or makikita natin. Tapos nag-stop tayo sa 3 kasi naka-indicate, sabi mag-end siya sa 3, hindi na siya include. So 0, 1, 2 lang ang makikita natin. Pag column, sinabi we want to start at the second column. The second column will be 1. Mag-start, di na kasama yung 0 kasi dyan din sa rows yan. Kung inuna ang 0, magkaka-error siya. Like, hindi magagalaw itong rows. Kung ang position ng sa columns ay 0, hindi magagalaw itong rows. Hindi gagagana yan. So, magsa-start tayo sa second column. Magsa-start sa 1. Sa 1 tayo magsa-start. Tapos sabi, in end before the 5th column, position 4. So, the slice is 1, 4. So, ang result ng position or output position is 1, 2, 3. Kasi mag-start tayo sa 1. Nag-start tayo, diba? 2, 3. Sabi, end siya ng 4. So, hindi nakasama yung 4. Nag-stop siya. Kaya 3 lang. Ito lang makikita natin. 1, 2, 3. So next, slices with dot law. Unlike iLaw, slices using dot law include the label after in the slice syntax. In other words, start underscore label, stop label. Namutan ko itong tawag dyan, sorry. So it includes the row column label start label, the row column label stop label, all rows columns in between. Let's use iLaw to select the same section of vehicles, the first 3 rows of the column from model to transmission. We need 2 slices. So row first row start to label 1940. Asa na ta? Okay. Yun yung pag location, gagamitin natin yung parang anong year, anong text, parang text, anong ID, anong model, anong like for example, nag-start tayo sa year, mag-start tayo sa 1940. 1663. Tapos nag-end tayo ng Ay, tama ba? Ay, nag-start tayo sa 1940 pero nag-end tayo sa 1663. Dun sa ano, sabayin, ID. Example na to ha. Okay. So, 1947, 18, 1663 ay ID number. ID number nun. So, magsa-start tayo sa 1940. Wait lang. Magsa-start tayo. Gamitin natin itong ano. Example natin dito sa dito. Kung sinabing ano, pag sa .lock, magsa-start tayo sa 12-1988. Start position to. 12-988, start position natin. Tapos ang end natin, 250. End natin to. So, kung sinabi, start tayo sa 12-988, tapos end sa 250, ang re-result, itong apat na magpapakita. Anong pagkakaiba ang .lock at saka .ilock? Pag ilock, hindi kasama itong ano, nasa stock. Hindi siya kasama ang 250. Ito lang visible. Ito lang, itong tatlong ID. 12988, 689, 950. Yun lang. Kung .lock, include siya. Include yung stop. Include si 250. Include siya. Kasama to. So, yun ang ano, pagkaka-understand ko. Sabihin natin na ano, ito yung ano natin, pag sa rows. Hindi. Ayan ang ano, sa rows. 9 ay, gamitin to natin itong sample. Hindi natin ito gagamitin to. So, 12988 hanggang 250. Kung pag-uusapan natin ang .lock, ito, magsa-start tayo. 2988 hanggang 250. Palitan na natin ito. Tapos, ito, lock, anong column nun? Anong naka-indicate? Imbis na ano, magsa-start, imbis na yung 1, 2, 3, text talaga po. Text talaga yun. Magsa-start tayo sa model hanggang transmission. Kung ano, ang result, ang lalabas niyan ay ito lang. Ito lang lalabas. Sorry. Ito lang lalabas. Ayan ang output. ID. Tama. Ito lang. Model, year, transmission. Yun lang ano. Di siya kasama sa ID. Dito kasama. Kasama yan. Pero hindi siya appear dun sa output. So, 12988, 689, 950, 250. Hanggang dun sa transmission, hanggang dun sa linya ng transmission, column ng transmission, hanggang dyan lang. Kasi naka-indicate, sabi, model to transmission. Kaya, hanggang transmission lang ang stop niya. Hanggang dyan lang. So next, if you don't specify a start value, the slice will start at the first position label. For example, for example, the iLock slice 3, they include row position 0, 1, 2. If you don't specify the end value, the slice will end the final position label. For example, the lock slice year will include every column starting at the year through the final column data frame. We specify neither starting nor the final value. The slice will include all rows and columns for the example of code. Okay. So, mag-start tayo dun sa data frame natin ay vehicles. Tapos, iLock. Saan tayo? Saan tayo mag-start? 0 to 2. E di itong lalabas to. Kung iLock, ito lang ma-appear. 0 at saka 1. Ito lang ang appear lang. Ito lang. 0 at saka 1. Kasi nag-start. Sabi stop tayo dun sa 2. So, dahil ito, sabi, indicate ito, ibig sabihin, simula dito hanggang dulo. Kasi, hindi siya naka-indicate kung saan tayo mag-start, saan ang end na, stop natin. Anong start position natin, ano yung stop position natin. So, kaya ganyan kasi endless yun. Kahit mahaba pa yan, hindi yan titigil hanggang dun sa end ng column, end ng row. So, yan ang ko. So, instructions. First, run the setup cell. Run natin to. Since ang data frame natin ay vehicles, parang naano ko na to. Okay. I-discuss ko na lang to. Use iLock to select the first 4 rows. And first 5 columns of the vehicles assigned in result of to slice. So, sinabi, first 4 rows, simula 0 to 4, kasi sabi, first 4 rows, kaya 4 rows tayo. So, start tayo sa 0, mag-end tayo ng 4. Tapos, yun ang nasa row. Nasa row to. Itong 0, tapos 4. Tapos, first 5 columns of the vehicle. Ito yung columns natin. Mag-start tayo. Dahil meron akong hindi. iLock to. Kasi pag location, mag-start tayo sa 1 pag nasa column. So, mag-start tayo sa 0. 0. Tapos, 5. Hanggang 5 columns tayo. So, save, run. Run natin. Ayan. May kita natin na 4 na rows. 4 na rows na may kita. Ayan. 0, 1, 2, 3. Sabi, dun sa columns naman, 5 din. Ayun o. First column, ID. Second column, model. Third column, year. Fourth column, transmission. 5, manufacturer. Yun ang pagkaka-understand ko. Kaya, test natin. Okay. Parang naano ko na tayo. Okay. And i-discuss ko na lang ito ulit. Use .log to select the Chevrolet rows in a setup cell. Output along with the vehicle type, fuel, and fuel configuration columns. Assign the results to Chevy. Chevy lang ang natin. Gagalawin natin. Chevy. Tapos, ang data frame natin. Data frame natin ay Chevy. Tapos, another data frame natin ay vehicles. Kasi anong class? Anong data? Anong kasama din sa ano? Saan galing tong Chevy? Nasa vehicles. Vehicle siya. Tapos location nun. Anong location ng ano doon sa Chevy? Hanapin natin. Ayan. 1 and 2. Kung tama yung ano ko. Tama. 1 and 2. Nasa row 1 and 2 yung Chevrolet or tinatawag natin Chevy. Anong location? Saan tayo Magsa-start tayo sa vehicle type. Dito tayo magsa-start. Ang start position natin ay vehicle type hanggang dun sa fuel configuration. Stop. Sabihin natin stop configuration. Stop position natin. Stop position. Ayan. Fuel configuration. As I said, difference ng dot lock at saka dot ilock ay magkaiba. Kung dot lock, magsa-start tayo, start dun sa 0 or start dun sa ID, mag-e-end siya, kasama dun sa end. Pag dot ilock, tawag dyan, magsa-start tayo sa 0, magsa-start tayo sa 0, tapos sinabi, stop at 3, pero hindi siya kasama sa 3. Before mag 3, naka-stop na siya. Or like, mag-stop siya. Kaya ang result, 0, 1, 2. Kasi, naka-stop. Naka-indicate na ang stop position ng ang stop position ay 3. Kaya hindi siya kasama. Yun. Hindi siya kasama. Okay. So, test work natin. Save, run, then tapos test work. Okay. Select all rows up to and including the 20th row and all columns from here through to the end. Assign the results to large slice. Large slice. Okay. Nasaan ang large slice natin? Titingnan natin kung ano. Large slice. Large slice natin. Basahin natin. Mayroon pa tayong slices. Okay. Wala. Okay. Like ko na. Large slice is ibig sabihin parang magsa-start tayo dun sa position na yan, tapos end wala. Like, ang end position natin hanggang sa dulo ng row. Dulo ng row. Yun. So, tawag yan? Saan tayo magsa-start? Start tayo sa 0. Start tayo sa 0. Ayun. Start tayo sa 0. Hanggang dun sa 20. Magsa-start. Dahil naka-ilock tayo. Yan natin. Dahil naka-ilock tayo, hindi nakasama tong 20. Kasi 0 is including I number. Kaya 0 or 1, 2, 3, 4, 5, 6, 7 to hanggang 20 siya. 20 numbers. 0 is consist of 0 is include siya sa mga numbers. So 0 hanggang 20. 0 hanggang 19. So 20 numbers na siya. So number 20 hindi na siya kasama. stop na siya. Stop position. Another 2. Magsa-start tayo. Ito ay ID, I consists ay 0. 0 siya. 0. 1. Column 1 ay model. Column 2 ay year. Kaya sabi, all columns from year to the end. So, magsa-start tayo sa year. Column number 2. Hanggang end. End siya. The reason kung bakit wala akong nilagay na number sa end position, as I said, hanggang sa dulo siya. Dulo ng row. Kahit mahaba pa yung listahan, mahaba yung rows, basta magsistop siya pagdating sa dulo. Yun. So, natin, run. Test work. Bakit? Wait lang. Ang tanong, bakit iLock ang pinili ko? Kasi sabi, select all rows up to including 20 rows. 20th row, what it means na 20 rows. 0 is consists of number. Kaya 1, 2, 3, 4, 5, 5 to. 6, 7, 8, 9, 10, 11, 12, 13. Number 19 is 20th row siya. Pwede rin location. Pwede rin lock. Pwede din dot lock. Pwede iLock. Pero depende kung anong ilagay mo sa rows. Saan ka mag-start, saan ka mag-end. Yan. Boolean math data questions often requires us to select data by properties instead of by position index. For example, we might want to select all rows in vehicles responding to the year 2023. If we filter the dataset by hand, we might go through the dataset looking at each row and comparing the year value to 2023. If they match, we keep the row. If we don't, we discard it. We can automate this process in pandas using Python comparison operators to compare values. The operator is a way of combining two variables to produce an output. In mathematics, for example, addition is an operator for combining two numbers, 3 plus 4. Compare 3 plus 4 to output 7. Comparison operators are operators that compare two variables to output true or false. Mathematics equals is a comparison operator. 3 equals 4 is false, or 3 equals 3 is true. Python has all the same comparison operators we know for mathematics. Double equal is Python's version of equality. Python's version of not equal to. Equal to, not equal to. Python's version of less than. Okay, back naman tayo ulit. There's Python's version of less than. Greater than, or arrow right, is Python's version of greater than. Left arrow equal is a Python version of less than or equal. Right arrow equal is Python version of greater than or equal. Whenever we compare two variables using a comparison operator, Python returns a true if the comparison is correct, and a false if it is incorrect. For example, there are few comparisons in the output. Kung sabihin natin, 3 is equal to 4, lalabas siya na false. 3 is less than 4 is true. Kasi less siya, mababa siya kaysa sa 4. ang 3. So, yan. 2. We can also use equals to compare non-numeric variable types. Car, truck. Parehas ba ang car sa truck? Magiging output niya ay false. So, pandas can perform comparison for entire column at once using the same comparison. For example, to determine which rows or year column contains 2023, we should use the code or, let's say, data frame. Tapos year. Year ngayon, year tapos equals to 2023. The output of this code series will be true for all rows where comparison is true. With year, itong year, parehas ba na 2023? Kung sinabi, parehas siya ng 2023, lalabas ang true. Kung 2020, parehas ba siyang 2020 sa 2023? Hindi. Kaya lalabas siyang false. Same din. Ito. Parehas ba ang 2023? Magiging true siya. Parehas ba 2022 sa 2023? Hindi. Lalabas siyang false. The output true-false series is called Boolean mask. When we think about the terminology, is that the Boolean mask allows you to see only certain features of a column while obscuring others. So, since a Boolean mask is technically just a series of Boolean values that frame series messages used before we work on a Boolean mask, it can be helpful to assign a Boolean mask to a variable. For example, let's assign the Boolean mask above the variable is 2023. Note that the same 2023 variable natin. Tapos, tawag yun. Data frame natin yun. Tapos year, 2023. Note that the single is what performs a variable assignment, the value being assigned is an entire comparison. Data frame year is equal to 2023. Two sides perform comparison. One performs the assignment to the variable. Hindi na setup. Start na tayo. Ang setup. Use Python to confirm that 28 is less than or equal to 40. Ilagay natin 28 less than equal to 40. Ilagay natin equal to true. Malabas siya. Kasi less siya. Less than equal. Less si 28 kaya sa 40. Kaya yun. Yun lang. This one. Okay. Create a Boolean mask that is true whenever best MPG is greater than or equal to 25. Assign Boolean mask to the GT25. GT25 data frame natin ay equals ang gamit natin ay equals best anong location anong type siya data type best MPG equals greater than equal or greater than equal to 25. So, save natin. Save. Run. And ang result natin ay 0. 25 ba siya? Because greater than equal ba itong 0? 2. 1. 21. Greater ba siya? False. Greater. Itong 29, greater ba siya? Yes. Kasi mataas siya. 18. Hindi. 19. Hindi rin. Hindi rin sila both na mataas or equal sa 25. Kaya sinabi double false. Okay. Create a Boolean mass with a true whenever vehicle type is sedan wagon. Assign the Boolean mass is sedan wagon. In sedan wagon vehicles this for equality. Okay. Vehicle type. Tapos equals ba siya sa sedan wagon? Tama. Okay. Baka ganito. Hala. Don't forget quotes around strings. Okay. Mutan ko yung part niya. Yun yan sa akin most of the time. Kaya, yun. Matagal pa to. Paano? Kaya, nintay ko pa. Okay, ayos na. Lagyan natin sedan wagon. Data frame natin ay vehicles. Vehicles bracket. Open close bracket. Vehicle type equals to sedan wagon. Sedan wagon. Tapos, save, run. It's not defined. Vehicles. Wait lang. Vehicles is not defined. Dahil na natin. Run. Okay. Run natin ito lahat. Run. Save. Run. Save. Run. Run. Natin. Save. Run natin ito. Ayan. Okay. Vehicle type. Tingnan natin. Tatanong natin. Equals ba siya? Parehas ba na sedan wagon siya? True. Ano ba siya? Yung pick up, parehas equal ba dun sa sedan wagon? Hindi. Kasi pick up siya. Vehicle type niya ay pick up. Sedan wagon, Equals ba siya? Yes. SUV? Hindi. Hindi siya parehas sa sedan wagon. Itong sedan wagon kasama. Equals ba siya? Yes, kasama siya. So, test work natin to. Boolean mass tells us which rows have certain property. What we usually want is a filter data frame done only with those rows. For example, the last exercise we create a Boolean mask. 2023 data frame year 2023 generated a column of true false based on the original data frame. Okay. To select only rows where this mask is true, we pass the mask to the data frame. Only the true rows from this 2023 will be selected. Note that it is necessary to assign the Boolean mask to its own variable. We can pass the comparison directly to the data frame. While this makes the code shorter and more efficient, it can also decrease the readability, especially when comparison becomes more complex. For now, we'll use variables to help clarify the structure of the Boolean filters. We build them step by step. As you feel more comfortable with constructing filters, you can start removing such intermediary steps. Hintayin na natin to. Since alam na natin kung paano natin Boolean mask, kaya medyo madali na sa atin to. Say, natin. Ay, run. Okay. Sabi, average of best MPGE is about 40. Create a Boolean mask to check each row for each best MPGE for greater than 10. Assign the mask variable to GT4D. So, mag-start tayo. Vehicles. Best MPGE greater than or equal greater than 40. Save natin, run. Save, run. Okay. Okay. Average. Create a Boolean mask. Best MPGE okay. Use the comparison GT40 from the last checkpoint to filter vehicles down to the only rows that are above average base MPGE. Assign the results to the above average. Pass the Boolean mask to vehicles using the square brackets. So, natin of average natin vehicles. At input natin ang data frame vehicles. So, bracket best MPGE checkpoint filter vehicles down to only rows. Natin. Pass the Boolean mask to vehicles using natin. Okay, gets ko na siya. vehicles, this VPGA files above average. Above average, natin greater than or equals to delta 40. Tapos, save natin. Run. Tama. Pinaglalagyan natin. Hindi siya. Okay, tingnan natin solution natin. Okay. Vehicles GT40. Okay, alam ko na. Use the comparison GT4 to the last checkpoint to filter ever. When the filter vehicle down to only rows with above average kasi kala ko kasi best target natin tong best VPGA. Kaya yung pala GT40. Comparison GT40. Asan yung GT40? Ay, nawala. Na naman. Ayan. Tingnan natin. Sana okay. Tingnan natin, pasensya na kung ganyan mangyayari. Kung ma-expect. Ma-expect na ganyan mangyayari. Diba? Okay. So, next. Ano na tayo? Greater than 40. Here's the GT. Ito yung nasa pala tayo. GT40. Okay. Mali. Save natin. Tapos run. Vehicles. Run. Mali. Baka di ko na run. Di ko na run to. Di ko na run. Have to run all. Kasi nagka-error sa info. Ayan. Lalabas na. comparison nasa na? Check natin. Test work. Okay. Filter vehicles down to only those rows where transmission is equal to auto. Assign the results to auto transmission. Gamitin natin vehicles. Equal transmission equals ba siya sa auto? Run natin. True. Filter vehicles down to only those rows where transmission is equals to auto. Test work natin. Wait lang. Run. Filter vehicles. Baka what he means na vehicles transmission auto. Yan. Sa vehicles under ng vehicles tapos transmission auto ba siya? Auto lahat. Okay. Next. Combining booleans with AND. US federal government created electric vehicles tax credit in 2010. What if we want a data frame of all electric vehicles models introduced after 2010? We will need to combine two different comparisons. Vehicles year greater than 2010 and vehicles fuel equals to electric. It operators allows us to combine comparison into a single true-false value. In it, operators and in English we may say this vehicle is electric and it was introduced after 2010. The word "and" indicates that the statement is true only if both components is true. The vehicle is indeed electric. The vehicle is in fact introduced after 2010. Python behaves exactly the same way. Two comparisons can be combined with and to test if both are simultaneously true. For example, we can combine 2011-2010. Electric is in parentheses, but in close parentheses to mark the two components for readability. 2011-2010 and electric. Output I true. 2011 is greater than 10. Yes, it's true. And electric is equals to electric. Equal to electric. Yes, it's true kasi parehas sila true. Both is true. Both is true. So, magiging output niya ay true. Kung isa false, tapos isa true, lalabas siyang false. Katulad siya ng math. Kung isang true, pag isa true, tapos pangalawa true, both true. Kung isa false, tapos isang true, or magkabaliktad sila, magiging false siya. Kahit mag-false, both ay false, ang output niya ay true. Yun ang ko. Yan ang explain ko. Medyo mabilis. Pandas also provide a version of AND, although pandas use the symbol AND. As we form our combined comparison in the following mini data frame. Okay. When we combine the comparison, the single line is more readable to do this piece. Okay. Is electric. Data frame fuel equals ba siya din sa electric? Equals ba siya sa electric? Sabihin na true, false. Tapos sasabihin, year GT 2010. Equals ba siya dun sa sa 2010? Itong year na yan. Ito, for example, year 2022. Greater than 2010 ba siya? Mataas ba siya kaysa sa 2010? Yes, magiging true siya. Kung iba, 2009, magiging false siya. Mag-appear siya ng false. Combined. Sabihin combined. Kasama ba yun? Is electric and year GT 2010. Magkaparehas ba siya? Magkaparehas ba siya? For lagyan natin. Sa isang row, bigyan natin ng example. Year. Ito, example na natin itong year transmission. Sorry. Year transmission. Ito, sasample na natin. Sabi, palitan natin itong fuel, gawin natin transmission. Equals ba siya sa auto? Equals ba siya sa auto? Kung sinabing manual, hindi magkakaroon ng false. Tagalin natin. Tagalin natin ng manufacturer, tagalin natin yung model, focus lang tayo sa year at saka transmission. Gawin na natin. Example ng gagawin natin. Lagyan natin transmission to. After ng data frame natin, na-input natin data frame, lagyan natin anong column kukunin natin. Transmission at saka year. Sorry. Yan ang parati minsan nangyayari din sa Kaya, pero bibigyan ko naman ng example. Ito na lang. Sasamplein na natin to. Habang kasi wala kasi signal. Kaya yun ang problema ko. Okay. Sabihin natin, fuel. Parehas ba siyang electric? Yes. Parehas siya. Parehas siya sa electric. Kasama. Parehas siya. Yung hybrid electric kasama. Parehas ba siya dun sa electric? Hindi. Lalabas siyang false. Lalabas siya ng false. Itong electric. Parehas ba siya? Same ba? Parehas siya. Kaya magiging true. Propane. Parehas ba siya sa electric? Hindi. Kasi ipagkaiba ang propane at saka electric. Kaya malalabas siyang false. Same. Yun din sa year. Greater than 2010 ba siya? Lalabas siyang false. Etong 2010, greater than ba ng 2010? Yes, kasi parehas sila. 2011, greater than 2010 ba siya? Yes, kasi 2011, mataas siya ng isang year. 2012, mataas ba siya kaysa sa 2010? Yes, magkaparehas siya. Mas mataas siya ng 2 years. So, sabi combined. Yung electric pa at saka year, true ba? Ba siya? Compatible. Compatible ba siya? Yun ang sabi ko. Pag parehas ang true, parehas ang false, magiging result ay true. Kung magkaiba, true, isa true, isa false, or false or true. False at true, kahit magkabaliktad sila, lalabas siyang false. Lalabas siya. So, electric, true siya. Itong 2009, false. Anong resulta? Anong resulta nito? Magiging false siya. Output niya ay false. 2010, true. Hybrid electric, false. Anong resulta nitong dalawa? Compatible siya. False siya. Kasi, false ito. Itong sa hybrid electric. Di sila magkaparehan sa electric. 2010, oo. Kasi same din siya sa 2010. Greater than 2010. Parehas yun sila. 2011, electric. Both ay true. Parehas ba? Yes, parehas siya. 2011, greater than 2010? Yes. Anong resulta? Ang output niya ay magiging true. Propane. Parehas ba siya sa electric? Hindi. 2012. Mas mataas ba siya sa 2010? Yes. Anong resulta? Ang output niyan magiging true. Kasi both, hindi. Magiging false siya. False pala. Propane, magiging false siya. Propane, dahil si propane, hindi siya parehas na sa electric. Hindi siya parehas ng klaseng fuel. Kaya magiging output niya ay false. Kahit tama itong year na to. As sabi ko, kung isang row may true, tapos isang may false, ang result niya, ang output niya ay magiging false. False. Yun ang ano ko. Here's the output combined. Ayan, makikita natin. Ayan. Magiging false siya. Magiging false. Magiging true kasi mataas siya. Tapos, parehas din yan. False kasi propane. That's 2012. Yan. Pwede natin pwede either gamitin natin itong combined or ito. Either of those two methods na pwede natin galawin. Pagka magko-combine tayo, lalagay natin data frame. Data frame is electric. Ito yung mass natin. Mass natin is electric. Tsaka yung GT2010 ay parehas pa siya. Hindi. Or pwede nang gamitin itong method. Depende. So, yun ang sinashort ko lang para maintindihan. So, first, run the setup cell. Okay. And then, Paris Agreement was a major climate change treaty enacted in 2016. The only comparison is in 2016. Is electric produced through or electric vehicles produced after 2016. Assign the results to combine. So, combine natin. Vehicles. Here. Year. And fuel. Tignan natin. Run. Natin. Ay. Mali. Year. GT. 2016. Yes. Electric. Sige natin. Run. Baka hindi siya open close parenthesis. Ganun open siya. Save. Run. Ano, mali ko dito. Wala siyang ano. Save. Run. Ayan. Wait lang.